Preparing for a front-end engineering at Netlify interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you explain the difference between server-side rendering, static site generation, and client-side rendering? Server-side rendering generates HTML for each request, static generation builds HTML ahead of time, and client-side rendering sends a JavaScript shell that renders in the browser. I choose static generation for content that changes infrequently because it is fast, cacheable, and resilient. SSR suits personalized or frequently changing pages, while CSR works well for interactive application areas. In practice, I prefer hybrid rendering, selecting the simplest strategy per route and measuring real user performance. While answering, define each rendering strategy, compare performance and infrastructure needs, discuss SEO and personalization, and explain how hybrid frameworks can combine approaches for different routes or components. Question 2. How would you optimize a React application with poor core web vitals? I would begin by identifying whether LCP, INP, or CLS is failing, using Lighthouse and real user monitoring. For LCP, I would optimize critical images, server response time, and render blocking resources. For INP, I would reduce JavaScript, split expensive components, and move work off the main thread. For CLS, I would reserve image dimensions and stabilize fonts. I would then verify improvements with production field data, not just a local synthetic score. Make sure to cover LCP, INP, and CLS, then discuss bundle analysis, image optimization, code splitting, font loading, layout stability, caching, and validation with field data rather than laboratory measurements alone. Question 3. How would you design a performant Jamstack website for a global audience? I would pre-render content wherever possible and distribute the generated assets through a global CDN. Dynamic features would call small, independently deployable APIs or serverless functions. I would use immutable asset file names, long cache lifetimes, responsive image transformations, and controlled revalidation for content updates. Localization would be represented in the root or content model. Finally, I would monitor cache hit rates, build duration, origin latency, and failures so the architecture remains fast and diagnosable. In your answer, talk about pre-rendering, CDN distribution, incremental updates, asset caching, image transformation, API boundaries, cache invalidation, localization, observability, and graceful behavior when backend services are unavailable. Question 4. What is hydration, and what problems can occur when hydrating a server-rendered React application? Hydration attaches React behavior and event handlers to HTML that the server already rendered. The server and browser must produce matching markup, otherwise React reports mismatches and may discard or regenerate parts of the tree. Common causes include random values, dates, browser-only APIs, and inconsistent data. I isolate client-only logic inside effects or client boundaries, make rendering deterministic, and avoid shipping unnecessary interactive code. This preserves fast first paint without sacrificing reliable interactivity. Be sure to mention hydration's purpose, server-client markup consistency, hydration mismatches, browser-only APIs, event attachment, delayed interactivity, progressive hydration, and techniques for isolating client-only behavior. Question 5. How do you decide between local state, context, and an external state management library? I keep state local when only one component or a small subtree needs it. I use context for stable, cross-cutting values such as theme, locale, or authenticated user information, while remembering that broad updates can trigger many renders. For complex client workflows, I consider a library with selectors, predictable updates, and strong debugging. Server data usually belongs in a query cache rather than global state. My default is the smallest scope that preserves clear ownership. Focus on state ownership, update frequency, component boundaries, server state versus client state, context re-render costs, selector-based subscriptions, debugging, and avoiding global state when a local solution is clearer. Question 6. How would you implement an accessible component library for a product like Netlify? I would start with semantic HTML and native controls, adding ARIA only when semantics cannot express the interaction. Components such as dialogues, menus, and tabs need explicit keyboard behavior, focus movement, and focus restoration. I would encode spacing, color, and typography as design tokens, then test with ACKs, keyboard-only navigation, and screen readers. Documentation should explain accessible usage, not merely display visuals. Accessibility becomes a shared library contract rather than an afterthought in individual features. Discuss semantic HTML, keyboard navigation, focus management, ARIA only when necessary, color contrast, screen reader testing, composability, design tokens, automated checks, and documentation for correct usage. Question 7. How would you build a resilient form with client-side and server-side validation? I would validate obvious issues on the client for fast feedback, but treat server validation as authoritative because clients are untrusted. A shared schema can reduce drift, while the server still enforces permissions and business rules. I would associate errors with fields, announce summaries accessibly, disable or deduplicate submissions, and preserve input after failures. Network errors need a clear retry path. On success, I would show confirmation only after the server confirms the operation. Cover schema reuse, immediate but non-intrusive feedback, accessibility, optimistic versus confirmed submission, server authority, network failures, duplicate requests, error mapping, and preserving user-entered data. Question 8. How would you investigate a production-only front-end bug that you cannot reproduce locally? I would first collect the release version, browser, device, root, user actions, and exact error details. Source maps and structured error reporting can turn minified stack traces into useful locations. I would segment occurrences by browser, geography, feature flag, and deployment time, then use sanitized session evidence when appropriate. If impact is high, I would disable the feature or roll back safely. After identifying the cause, I would add a focused regression test and monitoring. Mention reproducible evidence, release correlation, source maps, structured logging, session replay, browser and device segmentation, feature flags, privacy controls, rollback, and creating a regression test after finding the cause. Question 9. How would you structure a front-end deployment pipeline for a Netlify-style platform? Every pull request should create an isolated preview with the same build process used for production. The pipeline would run formatting, type checks, unit tests, accessibility checks, and end-to-end tests before merging. Builds must be reproducible, with locked dependencies and clearly separated public and secret configuration. Production deploys should be atomic, support instant rollback, and apply redirects and headers predictably. I would invalidate only necessary caches and expose deployment status directly to reviewers. In your answer, cover pull request previews, automated tests, build reproducibility, environment variables, dependency security, atomic deploys, redirects, rollback, cache invalidation, and promotion across environments. Question 10. What are the most important security considerations for a modern front-end application? I treat all browser input and remote content as untrusted, escaping output and avoiding unsafe HTML unless it is carefully sanitized. I would use a strong content security policy, secure headers, dependency auditing, and locked builds. Secrets never belong in client bundles, public configuration is not confidential. Authentication design must address token exposure, CSRF, and session expiry. I would also protect administrative routes server-side, because hiding a front-end control is not authorization. Be sure to discuss XSS, content security policy, dependency risk, CSRF, token storage, clickjacking, input handling, secure headers, supply chain controls, and the distinction between public configuration and secrets. Question 11. How would you design caching and cache invalidation for a statically generated site? I would give hashed JavaScript, CSS, and image files long immutable cache lifetimes because their URLs change when content changes. HTML needs shorter caching or revalidation so new deployments become visible quickly. For content updates, I would use incremental regeneration or targeted CDN invalidation rather than purging everything. Personalized responses must be private or uncacheable. The key trade-off is freshness versus origin load, so I would define acceptable staleness and measure cache effectiveness. Discuss immutable assets, content-addressed file names, CDN and browser cache headers, revalidation, purge strategies, stale content tolerance, deployment consistency, and avoiding accidental caching of personalized responses. Question 12. How would you improve the developer experience for a team maintaining multiple front-end projects? I would identify repeated pain first, then provide lightweight shared foundations, project templates, linting, TypeScript configuration, accessible components, build utilities, and reliable preview environments. Packages should have clear ownership, versioning, migration notes, and escape hatches. I would keep local feedback fast through caching and targeted tests, while C enforces quality consistently. Success means shorter setup and review times, fewer repeated defects, and happier teams, not simply more centralized code. Focus on shared tooling, templates, component packages, documentation, dependency governance, local development speed, consistent C, upgrade policies, ownership, and measuring developer friction instead of imposing abstraction blindly. Question 13. How would you test a complex front-end feature before releasing it? I test behavior at the lowest useful level. Pure transformations receive unit tests, component interactions receive integration tests, and a small set of end-to-end tests covers critical journeys such as sign-up or deployment creation. I add accessibility assertions, visual checks for shared components, and API contract tests where integrations are fragile. Tests should include loading, empty, error, permission, and slow network states. I prefer deterministic fixtures and meaningful coverage over chasing an arbitrary percentage. Mention unit, integration, end-to-end, visual, accessibility, performance, and contract testing. Explain test boundaries, deterministic fixtures, critical user journeys, failure states, and confidence-based release decisions. Question 14. How would you handle a front-end application that must work well on slow networks and low-end devices? I would prioritize usable HTML and CSS, then enhance interactions as JavaScript loads. I would set bundle budgets, remove unnecessary dependencies, split by root, compress assets, and serve responsive images in modern formats. Expensive work should be deferred or moved away from the main thread. I would design clear loading and retry states, cache-safe resources, and test on throttled networks and modest devices. Fast desktop performance alone would not define success. Cover progressive enhancement, critical rendering paths, JavaScript budgets, responsive images, lazy loading, compression, offline or retry behavior, CPU cost, reduced motion, and testing with realistic throttling. Question 15. How would you integrate a third-party API into a front-end without making the user experience fragile? I prefer routing third-party calls through a controlled server or serverless boundary when credentials, normalization, or rate limiting are involved. The client should receive a stable internal contract, while the integration layer validates external responses and handles timeouts, retries, and cancellation. I would expose useful loading, empty, and failure states without leaking vendor details. Metrics should capture latency and error rates. This design lets us replace the provider without rewriting the interface. Discuss a backend or serverless boundary, timeouts, retries with backoff, cancellation, schema validation, rate limits, fallback states, observability, secret protection, and isolating vendor-specific models. Question 16. What is your approach to responsive design for a product used across many devices? I start with content and constraints rather than popular device widths. Mobile-first styles establish a solid baseline, then grid, flexbox, and container queries adapt components to available space. Images and typography scale fluidly, while controls maintain comfortable touch targets. I distinguish layout changes from interaction changes. A hover menu may need a button on touch devices. I test with real content, zoom, keyboard navigation, and varied viewport sizes because fixed mockups hide important failures. Mention content-driven breakpoints, mobile-first CSS, flexible layouts, touch targets, container queries, responsive media, interaction differences, progressive enhancement, and testing real content rather than only fixed device sizes. Question 17. How would you prevent race conditions when fetching data in React? Suppose a user changes search terms quickly. An older request may finish after the newer one and overwrite correct results. I would cancel obsolete requests with abort controller and ensure the response still matches the current request identity before updating state. A query library can centralize caching, deduplication, retries, and cancellation. I also distinguish initial loading from background refresh, so the interface remains stable. Correctness comes before simply making requests faster. Cover stale responses, effect cleanup, abort controller, request identity, query libraries, loading state ownership, cache consistency, and avoiding state updates after a component unmounts or a newer request completes. Question 18. How would you introduce TypeScript into an existing JavaScript frontend codebase? I would begin at high-value boundaries such as API responses, shared utilities, and components with frequent defects. JavaScript and TypeScript can coexist, allowing gradual migration rather than a risky rewrite. I would enable strict checks progressively, replace implicit any deliberately, and use runtime schemas for untrusted network data because TypeScript types disappear at runtime. Shared domain types should be owned carefully to avoid coupling. Each migration step should reduce bugs without slowing everyday development. Discuss incremental adoption, compiler strictness, boundary typing, JavaScript interoperability, shared domain models, runtime validation, migration priorities, avoiding any, and keeping build and developer feedback manageable. Question 19. How would you use feature flags to release a risky frontend change safely? I would wrap the change in a flag with a safe default, expose it to controlled cohorts, and monitor errors, performance, and business outcomes during rollout. Both enabled and disabled paths need automated coverage, and flag evaluation should be deterministic for each user. A client flag controls experience, never authorization or data access. I would document ownership and an expiry date, then remove the flag and obsolete code after the rollout to prevent permanent complexity. In your answer, cover flag evaluation, targeting, defaults, gradual rollout, observability, rollback, privacy, stale flag cleanup, testing both branches, and ensuring server authorization does not depend solely on client flags. Question 20. Tell me about a front-end technical decision where you balanced speed, maintainability, and user impact. In one project, a dashboard was slow because every route loaded a large shared bundle. I proposed route-level code splitting and a smaller shared component boundary instead of rewriting the application. We measured bundle size, navigation timing, and error rates before and after, then shipped through a gradual rollout. Initial complexity increased slightly, but load time improved substantially and ownership became clearer. The experience taught me to choose measurable, reversible improvements before pursuing broad architectural change. Prepare a structured example using context, options, decision, measurable impact, trade-offs, collaboration, and follow-up. Emphasize user outcomes, reversible choices, and lessons learned rather than claiming perfection. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.